All right, here we go. On to B.3 and B.4. So we've done logarithms in base of A, right? And what we touched on right at the end of last year was logarithms in base E. So we have the logarithm in base E, and we write that as Ln, logarithm natural. And E is what we call a transcendental number. It's a bit like pi in that it's sort of a universal constant. And its value is approximately 2.72. E is 2.72. We call it Euler's number. Now, its physical significance, how we derive it, is not important to us at all. Okay? I can explain it, I can send you a video on it, but for now it's not something we need to know, rather it's just something that we use. Okay? So E is 2.72, it's a number that we use. That's all we need to know. That being said, we can have an interesting conversation about it a bit later. So I've said mathematical significance, not so important. Same log rules apply. Okay, let's get straight into these then. So we have example problems. We have ln e to the 2.2. So this is the logarithm in base e of e to the 2.2. It will simplify to 2.2. What does ln mean? It means log in base e. Okay, for b, we have ln of e to the x on top of 4. This is already expressed as a single power of e, so it will simplify to x on top of 4. Okay, in the next one, we have logarithm in base e of e to the x on the square root of e. We need to make that one single power of e. So, at the top I've got e to the x, and at the bottom I'll have e to the power of a half. The square root of e means e to the power of a half. And then we just use index laws. The top power take away the bottom power. Okay, same base, so the top power take away the bottom power, and we can't simplify that anymore. X take half, that's as simple as it gets, and so that's our answer. And just on that, we will accept x take half, we will accept x take 0.5, whichever you prefer, either of those is absolutely fine. Okay, so that's C, let's move on to D. So D is expressed a little bit differently. I'll point out the two rules are stated. ln e to the x equals x, so it's about our third line down. ln e to the x is x, and e to the ln x is x. So we have the logarithmic statement and the exponential statement. Okay? This one, question D, is an example of the latter. If we have e to the ln 4, Harry, Jack, let's pay attention here, it will simplify to 4. Okay, so that's the answer we're going to write in there for our notebooks for that one. Okay, on to E, we have e to the power of 2 ln 3. Now, it doesn't resemble this yet, which means I need to manipulate that power somehow. So if I look just at that power, 2 ln 3, I know I can write that power as ln 3 squared. I can take that number out the front, that coefficient, and make it the power. Okay, what's that? It's e to the ln of 3 squared is 9. So this is equal to this, is equal to this. We've expressed it in this form. E to the ln x is x. E to the ln 9 is 9. Okay, so just a little bit of manipulation going on there. That's e onto f. I reckon we'll fit f here. We have ln of e to the a times e to the b. These have the same base, so we can add those powers together. ln of e to the a plus b, and that will simplify to a plus b. Okay, on to question 2. Here we're solving logarithmic equations. Solve the following by applying e to both sides. So I'm going to start question 2 up here. Now we've got 2a, we have ln of x equals 2. Now, just like with linear equations, you can do anything you want to an equation as long as you do it to both sides. We are trying to get x by itself. If you want to get rid of ln, you put e to the power of both sides. Okay? E to the ln x equals e squared. If I have ln x equals 2, that's a statement of equality. I'm raising both sides, e to the power of ln x, e to the power of 2. It's still going to be equal. We've done the same operation to both sides. And now we know e to the ln x, that simplifies to x. Okay, e to the ln x will simplify to x. So how do you get rid of ln x? You apply e to both sides. Okay, that's what we're going to see when we're solving logarithmic equations. So that's our answer to A. Here we go for B. We have 3 take 4 ln of x equals 1. Now, before we apply e to both sides, we want to break it down. We only apply e to both sides when we have ln x by itself. That means I've got a little bit to do over here. I've got this 3 to deal with and this minus 4 to deal with. The first thing I need to do is get ln x by itself. So I'm going to subtract 3 from both sides. That's my first step. Okay, we've gotten rid of that 3. We're breaking it down. Then I'm going to divide both sides by minus 4. That's going to get rid of that one, isn't it? So we have minus 2 on top of minus 4. And minus 2 divided by minus 4 will simplify to positive half. We have the negative at the top, negative at the bottom cancels. 2 divided by 4 is the same as half. So we've broken it down. We started with this proposition and we've rearranged it. We've broken it down to here. We have ln x is half. How do we get rid of ln x? E to the power of both sides. E to the ln x is e to the half. And we know e to the ln x simplifies to half. Alright, so we're there. What do we do to both sides? E to the power of ln x, e to the power of the half. And then that one simplifies to x. Okay? So our answer for B is x to the power, e to the power of the half. Okay, on to C. We have ln of x squared equals 5. Now, you've got 2 strategies here. I'm going to show both. Both will work. Both will give you the same answer. The first would be that power can come out the front. We could write it as 2 ln x equals 5. Divide both sides by 2. And then raise e to the power of both sides. This will simplify to x, so we have x is e to the power of 2. The connection that we need to make, it's going to end up the same. Because we have ln of this thing by itself, we can apply e to both sides in the first step. So here's an alternative procedure. I can go e to the ln of x squared equals e to the 5. Okay? So I'm just going from here again, showing an alternative procedure. I've raised e to the power of this side, e to the power of this side. Now, on the left-hand side, that will simplify to x squared. So we have x squared is e to the 5. Then we square root both sides. And so we have x is the square root of e to the 5, which is to the power of a half. 5 times a half is 5 on top of 2. Okay? Alright, so that's C. Let's have a go at D. Clear some space. We've got ln of 3x squared, take ln of x, equals ln of 4. Okay, so we want to solve this logarithmic equation somehow. We're going to bring these two logarithms together, right? We have ln of a, take ln of b. ln of a, take ln of b. We're going to write this as ln of 3x squared on top of x. Okay, we're using those log laws. ln of a, take ln of b, ln of a on top of b. Now, 3x squared on top of x, that's going to give you 3x. All right, we have x squared at the top, x at the bottom. We'll simplify to 3x. Now, it's at this stage, right, I've got ln of 3x equals ln of 4. What this means is because we've got the natural logarithm of both sides, this interior component has to be equal. 3x has to equal 4. All right, 3x has to be 4 because we're performing the log of both sides. Not that you need to jump to that step. How do we get rid of ln? E to the power of both sides. So if I were to do that, equals e to the ln 4 simplifies to 4, e to the ln 3x simplifies to 3. We get the same proposition anyway. So just pointing out equality, and then divide both sides by 3 would give us x is 4 on top of 3. So we're solving these logarithmic equations. Okay. So that's logarithmic equations, but now we transition into exponential equations. So we solve logarithmic equations by applying e to the power of both sides. The opposite is going to be true for these exponential equations. We've seen these before. Let's do one. So, 16 to the x, take 5 lots of 4 to the x, is equal to 0. So there's going to be a few skills combining here. 16 to the x, we're looking along here, we need to factorize something. And I'm looking at that 4 and that 16 and going, they have a power in common. Alright? In fact, another way you can write 16 is that it's 4 squared. I might do this over here actually to save a bit of space. 4 squared, so we have 16 to the x. We could write that as 4 squared to the x, right? Which is 4 to the 2x, which is the same as 4 to the x squared. Why can we do that? Order of multiplication doesn't matter. 2 times x is the same as x times 2. 2 times 3 is the same as 3 times 2. So that's a legitimate operation. So what we have here then is we have 4x squared, take 5 lots of 4x. And if we're going to factorize, we're going, what's common? What's common between these two terms? 4 to the x. 4 to the x is common. We'll pull that out the front. So if I pull 4 to the x out the front, here I'm left with 4 to the x. And here we have to take away 5. Okay, if you expand this, you'll get what we had above. So we know it's correct. Okay, so that's the first step, we factorize, but we're trying to solve the equation. We're trying to say, what's the values of x that make this statement true? Well, let's apply the null factor law. The null factor law, reiterate. If a times b is 0, a is 0, or b is 0. They're the only two possible arrangements we can have, such that two numbers multiplied together will be 0. So this means 4 to the x is 0, or 4 to the x take 5 is 0. So applying the null factor law that we've seen in when we've done a fair bit of polynomials and so forth. Now, one thing we will develop knowledge in, and we saw in exercise 1A, is an exponential is never equal to 0. An exponential by itself, only if it has vertical translation will it be. So this has no solution. Alright, you can put that in your calculator, you can try and solve it. There'll be no answer that satisfies an exponential equation of that variety. Over here, there will be a solution, because if we're going to break this part down, the right-hand side down, Well, plus 5 to both sides. Okay? And here it becomes really clear. This is an exponential equation. It's an exponential because we have the power is the variable. Remember, we were comparing that with logarithmic equations. Okay? How did we solve logarithmic equations? We raised e to the power of both sides. How do we solve exponential equations? We perform the logarithm. Okay? They're inverse operations of one another. So I'm going to put ln on both sides. I'm going to perform the natural logarithm of both sides. You can do anything you want as long as you do it to both sides. What were we doing before? E to the power of both sides. What are we doing now? Logarithm of both sides. And then this x, that can come straight out the front using that power rule. X ln 4 is ln of 5. And this just means x times ln 4. We can divide both sides by ln 4 in order to get x by itself. Good. So that's our question 3. All right. The next one should be question 4. So let's move on to here. Make sure we get this done before lunch. So we have e to the x equals 2. Exponential equation. We're going to apply the logarithm to both sides. Ln of e to the x equals ln of 2. And ln e to the x simplifies to 2x. So that's our answer to A. Alright, for B, we have 5. Take away 3 e to the x is 1. We want to break it down. We want e to the x by itself. So our first step, let's subtract 5 from both sides. 1 take 5 will be minus 4. We've got minus 3 times e to the x, so we'll divide both sides by minus 3. And we'll have negative at the top and negative at the bottom, so those will cancel. We can make that term positive. And then we apply the logarithm to both sides. We've got e to the x by itself, so we'll apply the natural logarithm to both sides. And ln of e to the x is ln of 4 over 3. Okay, just here, an alternative way, the textbook is going to present it in lots of different ways. This could be written as ln of 4 take ln of 3, right? You can split it back up, all right? I'm accepting anything from there onwards. That's fine, that's absolutely fine. Okay, C, e to the 2x take 3 equals 11. Now we've got e by itself already, which means for this one, we're just going to apply the logarithm to both sides straight away. So we'll have ln of e to the 2x take 3 equals ln of 11. This becomes ln e to the 2x take 3 simplifies to 2x take 3. And then it's a linear equation that we're breaking down to get x by itself. First, add 3 to both sides. I'll write it like this, ln of 11 plus 3. I think it is useful to use the brackets there so that you don't just end up chucking the 3 in there. It's not ln of 14, it's ln of 11 plus 3. And then divide both sides by 2, or you can just half it. ln of 11 plus 3. Okay? That will get you x by itself. Alright, we can do it. We've got d, e to the x equals 9 on top of e to the x. Now, whenever we've got variables on both sides of the equation, we want to just move them to one side. And so what I'm going to do here is I'm going to multiply, remember you can do anything you want, as long as you do it to both sides. I'm going to multiply both sides by e to the x. Okay, still maintaining equality. And then here we'll have e to the x at the top and at the bottom. So that will cancel on this side as a product. We're left with 9 on this side and we'll have e to the 2x on this side. ln both sides. Okay, I'll just explain what's happened there. So we ln both sides. So we have 2x equals ln 9. X is half of ln 9. Full marks there. Okay, full marks there. But you could move that half up to the top, ln 9 to the half. And 9 to the half is square root of 9, which is 3. So an alternative way of presenting it. Very good. Last one. We have 2 times 0.6 to the x equals 10. Alright, so we want to break it down. We want to get the 0.6 to the x by itself. First, divide both sides by 2. Then we can log both sides. Now, I'll always do the natural logarithm. You can do log in base 10, you can do log in base 1500, it doesn't matter, as long as you do it to both sides. The same techniques apply. Move that power out the front, and then divide both sides by ln 0.6. So, really good work. Like, we've gone through a lot there. Today was always going to be a big lesson. Hopefully, a lot of it is sort of recall of stuff we've done. Now, that means ideally for homework, we would finish 1B. I understand that might not be feasible because you might have other commitments. So just do as much of it as you can. And in tomorrow's lesson, we will move on to 1C. We'll have a look at logarithmic functions. So 1B.1, 2, 3, 4. If you've got any questions that you want to ask,